Alright, today we are working on standard 6.2.4, explain how to multiply and divide positive fractions and perform the calculations. Our objective is to solve real-world problems involving the multiplication of fractions. So we're just looking at the multiplication part and being able to explain how to multiply positive fractions and perform that calculation. Let's look at some models. First of all, the numerical form, you can see here we have 2/3 times 1/2, in which you can see the model of 2/3 over here. And when we multiply it times 1/2, what we are doing is we're essentially trying to find out what half of 2/3 would actually be equal to. And if we cover it up with the shapes, we can see that half, we look at the area shaded in by both colors, half of 2/3 is actually equal to 1, 2 out of 3, 4, 5, 6 pieces in all. So we have 2 that are shaded by both colors. So our answer there would be 2 out of 6. But if I look even more carefully at this problem, I can see that it's actually 3 equivalent parts. There's 2/3, or excuse me, 2/6, and here is also 2/6. So we have 3 different areas of 2/6, and that is because this can actually be simplified by factoring out a 2 from the numerator and a 2 from the denominator to get 1/3. 2 divided by 2 is 1, 6 divided by 2 is 3. So we've actually already been using multiplication and division of fractions when finding equivalent forms. Now, how does this apply or relate to a real-world situation? If we could imagine this problem, we have 3 of 1/4. Many times in recipes, if you want to feed several people or more than what the recipe calls for, you may have to make like a double batch or a triple batch. And if the recipe calls for 1/4 cup of sugar or 1/4 cup of milk or something like that, you're going to have to triple that or multiply times 3. So we would need 3 of the 1/4 cups. So what we're saying is that we're taking 3 of, and we learned already that of actually means to multiply. So I'm going to erase this, and I'm just going to change it into a multiplication sign. If we look at our model, 3 times 1/4, I have 1/4 shaded in blue here, and I would just take this times 3. So I'm going to clone it 3 times. So now we have 3 of them. And if I put them all in the same shape, we can see that now we have 2/4, and whenever I put this one in to the same shape, if I separate this, then we have a total of 3/4 when we multiplied them. But what is actually happening is I'm taking this number 3, and I'm going to write it as a fraction, as 3 wholes, or 3 over 1. Now I can solve by multiplying the numerators. 3 times 1 equals 3, and multiplying the denominators. 1 times 4 equals 4. At the end, you should always look and make sure it's in simplest form, and this one is. So we're done with that problem. The very last problem, this is just another method for more complicated problems, and this is about factoring. We look at the denominator, which is the bottom set of numbers, and we notice that this number, 8, actually has a common factor with one of the top numbers. That common factor is actually 2. If we rewrote this problem as 3 times 2 over 8 times 5, we know that the answer we would get would be 6, and 8 times 5 is 40, and you would have to simplify this by dividing by a common factor. But if we take that common factor out before we get to the end step, what we're doing is essentially we're going to divide this number by 2, which is equal to 1, and we're going to divide this number by 2, which is equal to 4. And it will give us the simplest form then when we multiply. So let's try this multiplication again. 3 times 1 is 3, and 4 times 5 is 20. Is it simplest form? Yes, it is the simplest form. And we're done. Hope this helps you with solving real-world problems involving multiplication of fractions. Have a good day.